We are now going to look at one of the tools described in the last topic, Chapter 6, in more detail. In particular, we're going to look at Statistical Process Control Charts, or SPC Charts. So the objective of any process control system, regardless of how robust or extensive it might be, is to provide a signal when assignable causes of variation are present. So to fully understand this concept, we need to describe the different forms of variation that are present in every process. No matter the process, variation will be present in it. However, we are interested in segmenting the variation into two different sources. First, we are interested in natural or common causes of variation. Second, we have special or assignable causes of variation that we might encounter. Let's talk about each in a bit more detail. The first source of variation, natural, is also often called common variation. In essence, it is the expected amount of variation for the process we are observing. For example, suppose we are using a machine to cut wood into lengths that will then be used in the production of our end product, say an outdoor shed. By design, the machine will not be able to cut the exact same length every single time. Each piece of cut lumber will be very similar, but there will exist slight variations between the cut pieces. The common causes of variation may be attributable to things such as how the uncut piece of lumber was loaded into the machine, the sharpness, or really the dullness, of the blade doing the cutting, or even the amount of time the machine has been running. We could measure each of the cut pieces of lumber. These measurements would follow some probability distribution, and if the output measurements fall within some acceptable limits, then we would consider the process, quote, in control, or running properly. For our wood cutting example, maybe the range is plus or minus 1/8 of an inch. The second source of variation is called assignable or special causes of variation. These are often variations that can be traced back to a specific reason, like a change in the process. The goal is to discover when these assignable causes are present and then eliminate the bad ones and incorporate the good ones into the process. Eliminating the bad causes is straightforward and should be intuitively appealing to you. What about the flip side? When would you detect an assignable cause, decide that it is, quote, good, and then attempt to incorporate it into the normal process flow? Well, it really depends on what you're measuring. Suppose you work in a hospital and you're trying to eliminate the occurrence of pressure ulcers. Those are bed sores among the inpatient population. If during 1 week of your continuous observation you notice that the occurrence of bed sores has drastically dropped, well, that's a good thing. Yay, we're doing something good for the patients. You would want to examine why this drop occurred and then try to replicate it or incorporate it back into the process.